So question 5 in working with general trinomials. Notice again, we're trying to factor our trinomial completely. And again, notice, some trinomials are perfect square trinomials, but notice how this -48 tells me that this is not a perfect square trinomial. So this is kind of falling apart as a special product. So one things we could do is in general trinomials, if we have this x squared plus bx plus c, in other words, the quadratic term, its coefficient is 1. Again, a quadratic term means degree 2 term. Notice how the exponent of the variable is a 2, so we call this quadratic, degree 2. Linear term is what we call a degree 1, so degree 1 term. So notice how notice how this was actually a 1. We just don't put it there. And then the constant is just the number on the end. So quadratic term, linear term, constant. Now, since the coefficient of the quadratic term is 1, to factor this, all we have to do is focus on the factors of the constant, the c, but there's this trick. They have to add up to equal the linear term coefficient. In other words, they have to add up to the b. So if I look at this problem, for it to factor, the factors of a -48 must add up to a -2. So again, you can just ignore the negativity and just do the factors of a 48 without using the negative and just think, well, 1 times 48, 2 times 24. Is 3 a factor of 28? Not really sure. So I can just use your calculator. Let me get this picture out of the way. I don't have to do the table necessarily. I could just go 48 divided by 3, 16. So 3 times 16 is 4, factor of 28. 4 times 12 actually is 48. 5's not going to work. 6 times 8 does work. 7 doesn't. And 8 times 6 works. So what I'm getting are those factors there. Now, again, if you're not great at that, you could just go y equals and clear this off and put 48 divided by x. And then you could do your table. And it would just give you the 1 and 48, 2 and the 24, 3 and the 16, 4 and the 12, 6 and the 8. That's how the 8 and the 6 repeats. That's how you can stop. Now, if you really want to get gung-ho, if you're like, man, this is still a little much, you actually can type into your calculator -48. So -48 divided by x. So you actually can put the negative in there if you want. And it'll generate a table. Oops, take out the graph. So I'll sell 1 times -48, 2 times -24, 3 times -16, 4 times -12, 6 times -8. Now, what's interesting though is you scroll the other direction. Notice how it gives you -1 times 48, -2 times 24, -3 times 16, -4 times 12, -6 times 8. So notice how we have those actually positive and negative factor pairs if we want. So the catch is we need a -48, but the catch is we have to add up to get a -2 here. So we have to get this -2 here. So, to get a -48, if you don't want to make it too complicated with the table, you can just use your logic here. To get a -48, one of these sides has got to be negative. But since this is a -2, this is telling me that the left side's got to be negative. The bigger number's got to be negative. So this tells me that I'm looking at this side. And to get a -2, what's jumping out at me is this 6 and this -8. Because 6 times -8 does give me -48. 6 plus -8 does give me 2, because if you combine 6 to a -8, that's going to remove 6 negatives and leave me with 2 negatives, if we think it in those terms. Or again, you can type that into your calculator. So there's all kinds of things we can do here. So we'll leave it at that. But notice how we actually wanted the 6 and the -8 here because we needed the bigger side negative to get that -2. So that's probably enough on the calculator because you can really do all cool stuff on the calculator, but that's probably enough at this point. Let's just go ahead and factor this thing. So what made this easy is since the quadratic term had a coefficient of 1, all we have to do is set up two sets of parentheses. The x squared goes here and here. The factors of x squared, there's only one way to do that, x times x. But notice this -48 had a lot of choices. A lot of choices. But the choices that gave me the -2 was only one. So this tells me that use a +6 here and a -8 here. And that'd be the factorization. And the order could be different. You could have said x -8, x plus 6, because in multiplication order does not matter. So x plus 6 is a factor, x -8 is a factor, but it does not matter which order you put those in. So again, what makes this fairly easy is the coefficient of x squared is a 1. So all you ask yourself is, what are the factors of a -48 at a -2? If you know your multiplication facts, this becomes rather easy. So when you don't know those multiplication facts and stuff, then this becomes more of a challenge.